we'll start here. Good morning to all. Let us begin. Before we even jump into this, does anybody have any homework questions? Like yesterday. Yes? You got one? Sure. No. Some functions aren't linear at all. Like the function of first name, last name. If I tell you your first name, or in this class at least, because it's not repeating, I can tell you the last name. Not a linear, not even a line, right? But it's still a function. A function just takes an input and turns it into an output via something in the middle. Good question. Chances are there's very few perfectly linear functions in the world. Perfectly. Like, you can't drive your car at the perfect exact same speed all the time. Go up a hill, down a hill, it changes, right? Okay? You ready? Homework questions before we get started? All right, then. Then I ask you a question of, we've only had 2 days, so we might as well retrieve those 2 days while we're here. Does anybody remember what we did on day 1? That's the word, right? Functions. We're not going to do this every day because by the end of the year, you get crazy. Short definition of a function. Input, output. Doesn't have to be numbers. Doesn't have to be a line. Something comes in, something happens to it, something goes out. Right now, that's just looking like a number into an f of x. Later, it'll look like sines and cosines and tangents, if you remember all that stuff. Trigonometric functions are functions, even though they don't have numbers visible. Input turns into an output. Perfect. Even more specifically, you don't have to every single time. Input turns into exactly one output. I can't give you 2 test grades. That's not a function. And then the second name we did, domain and range. And if you want to relate the two, you could very quickly say that functions have a domain and range. And so it makes sense why you would learn those 2 things together. If you go, I posted yesterday's lecture, so if you missed Wednesday, not just you, other people too, I went ahead and on the video side of the website, so if you go onto the normal Blackboard link that takes you to the website, you go to Precal, lecture notes, videos, section 1.1 I didn't get because it was a bad day, but section 1.2 we did get, so you can click on that and watch if you missed it. Cool? You don't have to, but perhaps it is helpful. So that was functions, domain and range. Go watch it if you missed it. Now we're rolling right into actual mathy stuff. Rates of change and behavior of graph. So rate of change basically boils down to this one word that you've definitely seen before. That word in the middle right there. What's that word that I just highlighted? Easy question. Slope. There's a lot of ways to talk about slope. In, slope, change in y over change in x, change in output over change in input, distance over time, blades of grass picked, well y'all didn't do that, but blades of grass over number of trials, distance ran over time while running, number of spins over time passing. Something is changing on the top, and something's changing on the bottom. How do they relate to each other is kind of what we're getting at. Which is what we did yesterday, pretty much. That's kind of the entire lab was. 2 things are changing. Relate them together, right? So that's kind of where we're going with this. All right, I think we just roll right into it, because I know you've seen this in like the 9th grade before. The only thing worth really mentioning is m is equal to slope, is equal to change in output, is equal to change in y over change in x, is equal to y2 minus y1 over blah, blah, blah. F of x2 minus f of x1, because that's just a different way to write y, blah, blah, blah. but there's an arrow at the beginning. Because average rate of change, or this thing that we'll often abbreviate as AROC, if you see that abbreviation. I don't know why I did colons. Average rate of change is just slightly different. Because we calculate it slightly different. It's an average slope. It's not the exact slope at a point. So for instance, just so you know, it's not going to come up a ton. You're going to calculate it the same. That's a curvy line, right? If I take 2 points, that point A and that point B, those 2 points have a slope. We're not doing it. This is a next semester type thing. Find that slope right there. But there's an average slope between them. And that's kind of what we're talking about. That green line is the AROC. Now, all these other formulas are just how do you calculate that? I don't want you to think like, oh, slope, that means every line in the world is linear. Which was your question just a second ago? It won't be linear, but can you still calculate linear stuff about it? Sure. You might have ran a wild thing, faster, slower as you went, but you can still calculate your average speed, not your as the time went. That all comes a lot later too in class. We do more of that. This is just a brief overview. I just like to point out that we can't just put equal sign all the way across. Average rate of change, this is how you calculate it. But all of this stuff is equal. Okay, that's all the talking. Let's do the mathing. Use the table to find the AROC, or average rate of change, between those two dates. So we probably only need 2 spots on this table. That spot and that spot. Everything else is worthless. And we are going to label all of these things. All day is kind of going to be just an exercise in labeling. Cool? So there's 4 things we need to label. X1, X2, Y1, Y2. Let's go ahead and throw out some ideas. Any ideas on which one might be X or Y? Oh, I got some disagreement. Who said X? You said X? All right, you're saying X and you're saying Y. Why are you saying Y? I know exactly why you're saying Y. I know. And why are you saying X? Because why? Because you're saying because Y is the input, you want to call it X. And you're saying because Y is Y, let's just call it Y. Yeah, they're being mean. This is like, they did it. The book did it, but I'm glad they did it. They are just kind of being mean. You can call any variable anything, right? It's just a letter they made up. This is what we often see as X. And this is what we often see as f of X. Or the better way to think about it, this is the best way to think about it, is how Kiki just said. Actually, I just see the top as a input. I input the year. I get to output, I don't know, whatever 2.3 is, million people. Okay, here we go. I know that's mean. I do. I didn't make up the problem. So let's label these things. We've got X1 up top, which means right below it we probably have. And we've got X2, which means right below it we've got. And which formula looks like we can plug all that into it? I think so. So Y2 minus Y1 over X2 minus X1 equals 2, and we just slot them in where they go. Question? Don't lie. You're pointing and talking. Average rate of change? Right? Or slope. If you want to call it the slope equation, you can. You need a paper? So what are we doing? We're doing 2.84 minus 2.31 over 2010 minus 2005. That looks like a calculator if I've ever seen one. This would be an example of a time where your calculator would be allowed. If you see a decimal on a problem like that, then chances are it's on the calculator half of the test. If you don't see a decimal and it looked like it was a nice clean work, even if it was hard, probably on the non-calculator. What are we talking about? 0.53 over 5, which is actually 0.107. I made that up. I have no clue. Somebody. 106? Oh. I cheated. I did this 2 hours ago. No, I don't know how to do that in my head. I did this in class. I have Precal at 9, so. All right, zoom out real quick. Curveball was the Y being called X. Input, here's a thought, and then we'll go back to review what I was about to do. If you ever see time, guess what it's going to be? Yes. That's just a lesson in physics. If you ever take physics someday, if you ever see time, for the most part, we're going to be thinking about it as X. So zoom out for a second, let you look at it. See if you have any questions or I made a mistake or. All right. Yeah. Please, thank you. That's a good question. Yes, I'm going to say yes. In this class, on the tests that I give you or the quizzes I give you, yes. Could a table have it on the bottom? Sure. It's just labeled, whatever it's labeled. The reason we really know is if you just look at the formatting of those two dates. The formatting of those alone tells us, oh, that's getting inputted into some function C. C, I'm guessing, is cost or I don't even know what C could be. If you open up your textbook, though, I bet you it tells you exactly what that table's from. Because that's the try it one from the textbook. Probably should have included units, but that's okay. Cost? Capital? Consumption? Maybe it's consumption in millions of dollars? I don't know. Oh, cost. So that makes a lot of sense. Look at that. Cost of gasoline per gallon. So actually, yeah, definitely. 2.3. That's cost per gallon. So the slope that we just found was how much it's going up. So change in cost. Average, not just change. Average change. And some years cost goes up more than others, right? Some years cost goes up like crazy. Some years it goes down. Yeah. How about that? About every 4 years, gas goes down. Someone, because you want to get elected, you're like, hey, I'm going to lower the gas prices. Try to get elected. All right, let's do it again. Except this time they don't give us a table, so we have to make it. Which leads to a hard question that there's a mistake that could be made, and I hope you don't. What are these two things? Red thing, somebody wearing red. Nobody. Oh. Or pink. Red or pink. Expand it. What could we label that red thing? Comes straight off the last question. Arian, you're included in this. You got red on your shirt. Fine. More specifically, X what? That's not red. It's okay. You're right. It is the input. It's also X, and it's also X1. Cool. That's fine. I'll take it. All right. Nobody's wearing green. You're wearing green. Ah. Can't see me. This is the harder question. X1 is kind of the easier one. What is the 9? It is X2. The tricky thing that someone might say would be Y1, right? It's not a point. That is it. What'd you say? No, that's what I thought. Yeah, it's okay. The tricky thing is that they didn't say here's a point. If they would have said, here's a point, I don't know what the problem would be. But if they would have said, here's a point, 1 comma 9, it would have the curvy brackets. And B, it wouldn't be this type of problem because we couldn't do anything with the point. There's no slope on a point. There's a slope on an interval. So how are we going to find y1 and y2? This goes back to day 1. Yep. We did this on Monday? No. Yeah, we did. Monday we did this, right? F of x1 is equal to, take it one step at a time. Say 1? No, that's me. F of x1 is equal to f of 1, that's the first little step. And what do we do with that 1? Plug it into the function we already know, right? So 1 minus 2 root 1, which is probably negative 1. And f of x2 is equal to f of, no, f of 9, cool. I see what you did, but that's not. So 9 minus 2 root 9, which is probably 9 minus 2 times 3, which is 9 minus 6, which is 3. I don't know, you do the math. Okay. So we got our 4 things, don't we? Okay. So we're going back to the exact same formula, y2 minus y1 over x2 minus x1. And we're just going to plug and chug the things. So 3 minus negative 1 over 9 minus 1 is working out to be about 1/2. Red chunk is right there. Green chunk is right there. And we're subtracting the 2 things. Red parentheses, green parentheses, and we're subtracting the 2 things. I don't hate that at all, looking at it like that. Zoom in and pause for a second if you're looking at that. Let me know if there's anything that scares you or you don't like yet. Now this comes this is almost roll and circle back to yesterday's homework question at the beginning of class, I think, or Wednesdays. Because they've done something here where they're saying, hey, just plug in an A. Don't plug in a number, just plug in an A and see what happens. And so we're going to do that. We're going to plug in an A and see what happens. Back to it. All right, I'll change the color of the marker, but here we go. How could we label that 5? Blue shirt, blue hat, blue anything? What can that 5 get labeled on this interval? Thank you. And you followed the color rule. Awesome. This is fun. Orange shirt. Or a shirt that's about that color. It's very orange on my screen and very yellow on that screen. So, cool. All right, so what are we going to do with those 2 things? I don't even have to zoom out and look at the function yet. I really don't. I'm going to eventually. But right now, in my brain, I just said I have an interval. I have the first x and the second x. And now I know what's coming next. What could I find? If I have an x, I can find a... Sure, and how do I find that? Plug it in. So I'm going to go y1 is equal to, one step at a time, f of x1 one step at a time is equal to f of 5, one step at a time. Now I think I get stuck at my zoomed in state without looking at the whole paper. I'm saying if your brain just sees this ever, the word interval and interval, you know they're x's. If you have x's, you know you can find y's. And you get going with it, and then you get stuck. You're like, okay, now I actually do need that function. So let me roll back up there and find that function. So what do we do with that 5 from day 1 of class? Plug and chug. 5 squared plus 2 times 5 minus 8. I guess they just want you to be good at math. 25 plus 10, 35 minus 8. $27? Y2? Can you see that yellow? You said no? Oh. Y2 is equal to f of x2, which is equal to f of a, which is equal to yeah. Can we keep going? Technically yes, but I'm not going to because something cooler is going to happen. You're right. Could we factor it? I know this is actually it's a path that you can follow, but you don't know what's going to be cool until the end. But you're right. 8 does break down, doesn't it? Or in negative 2. Right? So then you go, not x. A plus 4, a minus 2. That's called factoring. If you don't like factoring, take a pause to plug Blackboard and the website. If you don't like factoring, you can hop over to the website. You can, it's fine. Click on hard topics. And guess who else doesn't like factoring? Oh, wait, I haven't done it yet. Oh, no. Okay, I need to add FOIL and box method right here. Keep change flip, exponent laws, radicals, distributed property. I've lied. Well, those properties, if you don't like those from previous things, you could go click on those. But factoring, if you don't like factoring, come to office hours and we can work on it. Box method, FOIL, whatever you like doing, the crisscross thing that I don't know how to do. Yeah, there you go. That's what he always says. It's not so much better. Okay. Whatever. Let's keep rolling and plugging it into the formula. Cool? So the formula is... Someone hit me over the formula because I put it down the past few times. What's that average rate of change for? Mm-hmm. Is equal to? What's our y2? It's that whole yellow thing. A squared plus 2a minus 8. Subtract the blue thing. What's the blue thing? And then what goes on the bottom? A subtract 5. Those colors kind of help see where each little spot of it's coming from, if it's ugly and long like this. Now there's one thing that can be combined, and this is why I didn't want to use your idea. There's no way for you to know. Do it both ways and see what happens. You're about to see though. There's only one thing that gets combined here. The 8 and 27. So now we're actually left with a squared plus 2a minus, is that 35? And a minus 5? You know what that top gets to do? Turns into a plus 7, a minus 5. Isn't that true? Shameless plug for office hours. come to my office right before this class. We can practice factoring. So we're just looking at a plus 7. I will shamelessly plug office hours all of my life. Right before this class, for an hour, I'll be there. Also on Tuesdays and Thursdays, I have a time all day pretty much, but the official thing is Monday, Wednesday, Friday, lunchtime. Cool? I think I need to pause, not to change an answer. It doesn't change anything. It's just a note that doesn't affect this problem, but I like to add it as notes when I have extra room, blank space, and time. As we become better math thinkers, something somewhere along the way happened where our brain should have stopped and said, I got to make a note of something in my brain. I need to pause and make a mental note of this one really specific thing that we have already talked about in the past week, Monday, Wednesday, or Friday, that you really should. There's no like math step. It's just a pause and to think about something. Everybody see something that we probably should make a mental note of? Or, hey, this happened and I think it's kind of weird. I'll give you a small hint. We did cross them out. Over here? Wait, what are you talking about? No, I'm not asking you to do anything else. No more math, no more writing. I'm just asking for a small mental note from either Monday or Wednesday or Friday that our brain really should make. Not because it affects this problem, because it actually doesn't. But it might. At the end of the day, it might affect something, depending on what they're asking for. Better hint, I'll narrow you down. It was on Wednesday. It was a really important part of Wednesday. I would say it was half of Wednesday. I would say if you had to break Wednesday into two different things, it was one of those two things. What? Yeah. That's what the title of Wednesday was, right? Huh?
Oh, it's the bottom.
Yeah, look at the bottom. We don't have to do it because it didn't ask us for domain. But our brain should think, and especially with something this easy, this small of a bottom, I could look at that immediately and say, I have a rule. I have an idea. What do we know about the bottom? Which means, no, it's not bad. It's not bad. It could be. It's not. That's the small note, right? Because this is such an easy one to do, and it's just right there, and it pops up in the middle of the problem. I just make this small note in my brain up to the top left, to the top right of the problem, as you get to be a better math thinker, that the bottom can't be 0, right? You don't have to write it. You just think it. Bottom can't be 0. Oh, that means that A can't be 5, right? Don't add it in there so as to trip yourself up. Just up to the top, somewhere off to the side, right? A better not be 5. And now what if you get to the very end of your problem and your final answer, because that's what it asked for, was, what's A? And then it was 5. You'd have a problem, right? We'd have to deal with that. This is not that. Our final answer was A plus 7. A plus 7 is not 5. But, good to know. Cool? Okay. I just think it's really important to start as you see denominators pop up, or square roots and radicals pop up, to start making these notes in our brain of, hey, I need to think about domain restrictions. All right, we'll get to do something easier. That was a little harder. How much time do we have? Oh my goodness. We get to do something a little easier now. Increasing and decreasing. If I were to tell you that the function is increasing on this green line right here, because it's like a roller coaster and it's going up, then I would ask you, what is that interval? And that's where that blank down there. It used to be filled in as just a definition, and I erased it and put a blank so that we could practice writing intervals. That green is increasing. I labeled it as increasing. I highlighted it green. What's the interval? Cool, comma, -2. We didn't look at y because interval is the x. We're looking at the x boundaries on the interval. Okay, so I'll say they were nice enough to give us 2 blanks. Where's the other increasing interval? Probably up there where it's increasing, right? Sweet. And if I change my highlighter color to red, I can tell you the one spot is decreasing. It absolutely is. -2, comma 2. And we're throwing parentheses around all those. But if you were to throw brackets, you'd get full credit. My open math for homework. For the homework, use the parentheses, but it tells you on the homework to do that. If you read our textbook, it says either or good. Not for infinity. Infinity is always parentheses. I'm talking for the 2's down there. Infinity, you don't get to do either. That's not true. That's bad. Infinity is not an actual number. It's not a real number, so we don't get to bracket it. But if you were to bracket the 2's on a test, you'd be fine. That one? It could be either. It's a parenthesis because of my open math. This one? Is that clearer? Awesome. Thank you. Good question. Not too bad. That's all of it. Is that right there? That thought. Left to right, like you read a book in English. Up. If you're roller coastering up, increasing. If you're roller coastering down, decreasing. And you write them just like we learned domain and range intervals. Okay. That's the whole thing. Questions? That's way easier than the first thing we did, which is the plug and chug for 4 times. Awesome. Last but not least are these things. I'm going to do all 4 at the same time because it's fun to think about them. Called local and absolute mins and maxes. So that'd be to say, if we were all to stand up and I would say, who's the tallest person? Who's probably the tallest person, actually? Who? Luke? Probably. Luke might be the tallest. Maybe somebody else, right? Does that mean Luke's the tallest person on campus? No. But if you localize it to the room, which is the word local, Luke's tallest, right? Zoom out a little bit, there's probably a tallest person on campus. Zoom out a little bit more, there's probably a tallest person in Houston, right? Yeah, and keep going and keep going. But it also is true that there's a fact that there is an absolutely tallest person in the world, right? So there's an absolutely tallest or maximum number of a function. But there's also a bunch of little local biggest numbers too. Same with minimums. So the way that works itself out is if you can zoom in and see a little maximum, the way a maximum as a function kind of looks like that, right? If you can zoom in and see a little maximum, you got a local max. You can zoom in and see a little minimum, that's the max right there. Sorry, I should have labeled it. That's the max. That's the min. If you can zoom in and see a little min, that's the min. Absolute doesn't, you don't have to zoom in. You look at the whole thing, you say, what's the tallest number? What's the smallest number for the whole thing? Okay, so let's, I'm going to skip, try it 4. Then I'll let you do that during the break or during lab or whatever because it's a Desmos thing. Hop over to Desmos and try it out. Explore on a graphing calculator even though we don't use them for the test. That's why I threw example 10 on here because it's a little more clear. Okay, I'm not going to go write them yet. I'm just going to go and look. Anybody see a zoomed in tallest person or zoomed in maximum? Right there, right? Okay. That is a local max. Good call. Anybody see another zoomed in tallest person? That's a different local max. I'm just going to do the locals right now. Anybody see a zoomed in shortest person? That's a local min. Okay, now we have to fight with these endpoints, right? If they are endpoints technically local mins, well, if you zoom in a lot, right? Can't really zoom in farther than that, sorry. But if you zoom in enough, do you know what happens on the other side of that dot? Like, it's not even on the function. The other side of that dot doesn't exist. And so, it's not local to look at it as a min, because the rest of it's not even on the interval. We don't know whether it would have been. We don't know whether this would have done that or that, right? We don't know whether it would have been localized or not. So we're just looking at those little shapes when we're talking local max, local min. You need something on the other side. If you want the math words for that, we can look up here and say that this interval from, I know this is a lot of definition, but the interval has to exist. Right? There has to exist an interval from A less than B less than C such that it's in the middle of the two of them, right? B is in between A and C for it to exist. There has to be a point B in the middle, and that endpoint is not in the middle of anything. That endpoint is at the end, right? So that's kind of the math behind it. Is it actually has to have a point on either side for you to consider whether it's local, min, or max. Erase that. If you see that shape, it's a max. If you see that shape, it's a minimum. Cool? But now absolutes are a little bit different. What's the absolute tallest point on this blue line? Boom. Absolute max. Absolute minimums are a little bit easier. You don't have to worry about these endpoints. You don't have to worry about everything. What's the absolutely shortest, lowest, most negative thing on this graph? Yeah, about, right? Negative 10? Absolute min. And now it's just a matter of working out, hey, how do we write these? So I'll show you that and then we'll be done for the day. A little over? No. Oh, wow. Good job, me. Sweet. Okay, so let's do green. So where's the first local max you see? So local is y equals 16 at x equals negative 2. I know that's not a way we like to write our answers, but that's the local max. Is y equals 16 at x equals 2. There's also another one, right? Y equals 16 at x equals 2. True? And if you want to beef up your answer, that's the answer. If you want to beef it up and say this occurs at 216 and negative 216. That's easier, but that doesn't tell me. I don't know. I actually don't know. I like that answer, right? That's a good answer. Every textbook, we talked about it last year, maybe every textbook ever always says, if you look right here, the local minimum at this is this, always. They always just say, it's max is this number, it occurs here. Just they want to be really explicit with the answer and tell you exactly what they're thinking. Because the word max means maximum. It doesn't mean a random point. And it's not maxing out the x. So if you were to answer, like, the maximum is this point, well, the maximum what, x or y? So that's why we stick to one answer. What about local min? Y'all tell me, since I'm talking a lot. Y equals 0 at x equals 0. Or if you want to beef it up, you could write a little sentence even. This occurs at the point 0, 0. That'd be the best answer. The minimum is 0. This occurs at x equals 0. This occurs at the point 0, 0. You write that whole sentence out, then someone's like, oh, this person loves math or knows what they're talking about. Absolutes are a little easier because there's only ever going to be one of them. The absolute is y equals 16. Oh, it's the same answer. at x equals 2 and x equals negative 2. This is at the point 2. It's the exact same answer. I could have just copied and pasted. Now, if they don't ask you where it occurs, I suppose you're technically fair game to just write the number 16 and be called a day if they don't actually ask you where it occurs at. But I would never do that. I would always tell them I know what this is and I know where it is. And then the absolute min would be y equals negative 10, and this occurs at no 3. You knew that. So that would be 3, negative 10. Look at that timing. Getting good at this. All right. I know that's a lot of information today. It's like a lot of 3 random different things. It's like, hey, know about plug and chugging 4 times for slope. And also know about increasing and decreasing. And also know about ups and maxes and mins. 3 different things. But all 3 things could be like summed up in behaviors of graphs. Even slope. Technically, we didn't need to say rates of change because slope is a behavior of a graph. It's whether it's going up or down, right? It's whether it's increasing or decreasing. So this whole thing is summed up in graphs behave a certain way. They either increase or they decrease. They have a positive slope or a negative slope. If they turn around and go from positive to negative, it's a max. That kind of thing. This whole thing is wrapped up in behaviors of graphs. All right. That's it. We're going to take a 10-minute break. You're going to clap. Break. We'll take a 10-minute break.